ahead and hit record, and we're going to so first of all, the newest questions that you're going to see on this test are going to be heparin and insulin infusion questions, and then the heparin bolus weight-based protocol. So let's work through a couple of those. And then I'm also going to show you a alternative reconstitution type question that you may not see this semester. You might see it in fourth semester, but I've been told to make sure I show it to you guys, so because it might be coming to you down the line. All right, so before I get to the heparin proper, I just want to show you the these are workup questions for answering the weight-based heparin protocol. In that you are doing some practice where you're converting and going from one flow rate to another flow rate. So you're starting with units per hour and you're converting to milliliters per hour. So going from one flow rate to another flow rate. The reason I start with this is because you're going to see this repeated, at least the steps that I'm going to kind of go through when we get to the weight-based heparin protocol. Also, what I'm showing you heparin infusion wise is the same thing as insulin infusion. It's the same steps that are involved. So what I'm going to do is I'm going to take my initial flow rate of 500 units per hour. And what I want to do is I want to convert that units per hour to milliliters per hour. And what I need to do is use what I have available. What do I have available? I have the 1,000 milliliters, find my thing, of IV with heparin, 25,000 units. So that's my available in this situation. So I don't want units. I do want milliliters. 1,000 milliliters, 25,000 units. I'm going to plug that into my calculator. $500 times 1,000 divided by 25,000 gives me 20 units, or I'm sorry, 20 milliliters per hour. If you're trying to do ordered over available or order over have for this question or this question type, you might have some struggle with it just because you have to keep in mind what's the order, and that's going to be your 500 units per hour. Your available is the 25,000 units per 1,000 ml. So there's a lot of variables there. I do think that knowing how to do dimensional analysis is going to be helpful. But if you're doing this a different way and you're getting the correct answer, you're doing it right. I'm not here to tell you that you're doing it wrong. Just know that it's just an alternative way of doing it. So, all right. So I wanted to show you that first, just because any of these questions, you're going to do the exact same thing, including insulin. All I did was I went from one flow rate type, 25 units per hour, to another flow rate type, milliliters per hour, and I use my IV as my available. All right, so let me go to the heparin protocol. So, and then I'm going to do this with a different patient weight. That way we can look at it fresh together. So you already have probably seen the 110 pound. Every time I do this review, I choose a different patient weight. So just so you know, if you ever go back and you're looking at it, you can usually skip to the heparin protocol and see what what you need to do. All right. So when we're looking at the heparin protocol, first of all, what I have boxed here in red, this is what you would see if you type in heparin protocol or weight-based heparin protocol into Google. You're going to see all these steps listed, 1 through 15. Okay. I should have, when I originally put this together, I should have made this so it looked more like a almost like a separate, like an inset, as opposed to, you know, tell me what the CBC would be. Tell me what when the neurocheck should be. Remember, this is a math test. So what we ultimately care about, or what the department ultimately cares about, is can you do the math to answer the questions relative to answering uh, answering this. So, and I know the answer is yes. So now I'm just going to show you how to kind of navigate this thing that's called the heparin protocol. The first thing is, when it says protocol, it's going to tell you an order, and the order is to bolus the patient with heparin 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. So that's your order. They even repeat the order in step 10 of the um, protocol. And again, they say bolus with 80 units per kilogram, start a drip at 18 units per kilogram per hour. So it gets repeated. Okay. The next piece of information that's important to know is step 2 of the heparin protocol, and that is what's your available. So you have an IV and you have a bolus injection or injectable available. The IV is 25,000 units and 250 milliliters, half normal saline, and your bolus dosage strength is 1,000 units per milliliter. So you have two different availables, and one you're going to use for your IV infusion rate, which is the 25,000 units, 250 ml, and then one you're going to use for your bolus dose calculation, which is the bolus dose strength of 1,000 units per milliliter. So let's work through one of these problems, and let's change the patient's weight. Let's make this patient 200 and let's see. Let's say 237 pounds. Okay. Now I like to choose these random numbers because what I'm hoping to get is, when I take 237 divided by 2.2, I'm likely to get a number that has decimals after it. I think your instructions may vary, but I've always rounded this step to the nearest tenth. That way I'm not trying to carry over all these decimals. And in reality, if the patient's weight is like high enough, meaning that they're over 100 pounds, the decimal values shouldn't matter towards the end of the equation. You can test that out yourself. Just leave the variable in there, but I'm just adding more confusion. But anyways, so 237 divided by 2.2 gives me 107.727272 repeating. So I'm going to say 107.7 kilograms. If you wanted to say 107.72 kilograms, I think you'd be perfectly fine. I think you'd be wrong to say 108 kilograms, at least for what we call the CCAC math bubble. I would say that you would probably get a slightly different answer if you rounded it all the way up to the nearest whole kilogram. So my recommendation is round to the nearest tenth. All right. So on your test, you're going to see one of two scenarios. Scenario one is they're going to ask you to calculate the bolus dosage strength and the initial infusion for your patient. So you're going to see part A, part B, and that'll be your one question. You have to answer those two parts to answer the one question. And in order to get full credit, or in order to get credit for the question, you need to answer both correctly. If you miss one or both of the questions, you've only missed one question. So don't fret. It's not two questions that you miss. You've only missed one question, but you need to answer both parts of the question in order to get the whole question correct. So you'll either get the initial bolus and the initial infusion rate, or you'll get a after they've been on the infusion, then we recalculate and recalibrate based off of what the APTT is. So let's go through the initial bolus. So patient's weight is 107. Actually, I always forget that I can just copy and paste some of these things here. And that way I can kind of just move this where I want it. All right, so that way I don't forget and come back to it. So my patient's weight is 107.7 kilograms. What I'm going to do is I'm going to multiply by what it tells me to multiply it by, 80 units per kilogram. So 107.7 sounds like a radio station times 80 gives me 8,616. That's units. Now, I don't want units. I want milliliters. So there must be a way to convert units to milliliters. So we're talking about our bolus. So we're going to go back to our bolus dose strength. And you can see it's right there. And it says 1,000 units per milliliter. So that's what I'm going to write. 1,000 goes with units. 1 milliliter goes with the milliliter. We've eliminated units. And this also should look very similar to what we just did previously, where we went from units per hour to milliliters per hour. But in this situation, we're just going from units to milliliters. So we're not doing a rate. We're doing just a single injection or a single dose. So what I'm going to get then is an answer of 8.6 milliliters. All right. So that's how you would calculate for the initial bolus. For the infusion, now we're going to take the same patient, same weight, 107.7 kilograms. And my order says to start them on a drip rate of 18 units per kilogram per hour. Now, I will tell you, they use that term drip only because it is coming out very slowly. They're not asking you to calculate a drop rate. In fact, they even tell you calculate the infusion rate in milliliters per hour for the heparin drip. Okay, so they don't want drops per minute in this, just to let you know that. The other thing is there's nothing in any of the protocol that says anything about tubing or giving you a drop factor. So even if you wanted to calculate the drop rate, you couldn't do it because you don't have that information. So you don't need to worry about it. And then some of you just went and said, I wasn't thinking that at all. Why'd you mess with my head? All right. So 107.7 times 18 gives me 1,938.6. 0.6. And this is units per hour, because we got rid of kilograms. So units per hour should look familiar. We're going to need to convert units per hour to milliliters per hour, because that's what it told you to do, right? It told you to look for milliliters per hour, just like it told us to look for milliliters of our bolus. So I need to have a way to convert units to milliliters. So I'm going to go back up to my protocol, look at my available. So we're not doing a bolus dose, so I'm not going to use the bolus dose strength. I'm going to use my IV. And my IV says 25,000 units, 250 ml. So that's what I'm going to put here. 25,000 units, 250 ml. Units cancel. I'm left with milliliters per hour, so I know I've set it up correctly. And then when I do my calculation, after I round, I'm going to get 19.4 milliliters per hour. Now, in reality, when you're programming this into the infusion pump, you might just put 19, or you might have to either put 15 or 20. It just depends. But when we're talking about math, they want you to round to the nearest tenth when it comes to volumes, including milliliters. If it's drops, you round to the nearest whole drop. If it's capsules, you round to the nearest whole capsule. But if it's a volume that involves milliliters, they want you to round to the nearest tenth, unless they tell you specifically otherwise. So what I'm going to ask you to do now is just to get some participation. I want you to go ahead and do the next two steps, the bolus milliliters, and then the new infusion rate milliliters per hour. So we're using the APTT of 43 seconds. The patient's weight is 107.7 kilograms. And then this is the information to use based off of the protocol. Rebolus with 40 units, and then increase the rate by 2. So go ahead and take a few minutes. And when you have an answer, just go ahead and type both answers into the chat. So I'm going to give you some time to work on that. All right, so it looks like everyone's getting what I got, which is 4.3 milliliters for the bolus and 21.5 milliliters per hour for the updated infusion rate. So I'm just going to write the answers to that 4.3. Obviously, that's rounded. And then 21.5. Obviously, that's also rounded. So good job, everybody. Good. Yep. All right. So I worked one through with you guys. You worked some through on your own. The thing that really changes in the heparin protocol is just the patient's weight. And then so if I always tell students when it's getting to like crunch time, if you want to just do a couple of these practice wise, just choose a weight and then come with your final answer. Remember to round to your nearest tenth. And if you want me to double check your work, you can just email me. All I need to know is the weight that you used, and then I will confirm, or I can let you know and give you feedback that you answered it correctly. So you can always email me that if you'd like. The last thing I'll mention as far as what I had prepared, so I'm still here, I'm not leaving or anything, but the last thing that I'll mention is this reconstitution variation that you might see later on down the road. So you may not see it this semester's test. I don't think you will. You might see it fourth semester and later, or obviously hopefully you're done taking tests after that, but in fourth semester. And basically, if you recall, when you look at a typical label, right, your typical label will give you the information you need to solve your question. So like, let's look at this morphine label. Morphine sulfate is available at 15 milligrams per ml for that particular strength. So if I'm going to give that, the patient is ordered 45 milligrams, I'm going to pull out or I'm going to withdraw 3 milliliters, and then that's what they're going to receive via intramuscular injection. So you see that all the time, like 10,000 units per milliliter. It gives you the volume. What's different about this reconstitution question is just that the label's a little bit different. So the first thing that stands out when I look at this label is first of all, I know it's intramuscular because the order says intramuscular. So I know I'm looking for milliliters of this medication. But if you look at the label clearly says 500 milligrams. It doesn't say 500 milligrams per ml, per 2 ml, per 5 ml, per 15 ml. We have no idea what it is. So that's your clue that if you see a question like this, that you need to look over here at the instructions or the directions on what to do with this reconstitution. What a reconstitution is a powdered medication that the pharmacy is going to add water to. And then in some clinical settings, you as the nurse may be adding sterile water to these injectables. So the 500 milligrams is correct as a powderized form, but in order for it to be injected or used as an IV, we need to incorporate it into a liquid. Okay, so it's just like, making, like if you do protein drinks, right? It's powder, you add it to milk or water or whatever you do, shake it up, and now you have a shake. This is it's not different other than what we're talking about. So protein shake versus an antibiotic. All right. So you're looking at the instructions, and it tells you for intramuscular administration, you're going to add 2 milliliters of sterile water for injection, shake it up, withdraw the contents, and then that you're going to get a total volume of approximately 2.2 milliliters. So you actually don't need to worry about the 2 milliliters of sterile water added or even the total 2.2 milliliters. What you're looking for is right here, what I circled. The strength of this after it's mixed is 225 milligrams per milliliter. That's the information you're going to use to solve the equation. So that's your available. So the trick to this is just knowing where to look for it and where to find it. So I would take my order, which is 375 milligrams. All I did was convert 0.375 grams to milligrams. Then I'm going to divide by my available, 225 milligrams, multiply by my quantity, 1 milliliter. And then after I round, I'm going to get 1.7 milliliters as my answer. If you look at some of the other example, and there's several example labels that I have posted on the OneDrive folder. You might see some of these reconstitution questions where they'll tell you, you'll see 500 milligrams and then you'll see the total volume. You might have to do that calculation on your own. So like 500 divided by 2.2 is going to be close to 225 milligrams, but it's not going to be exact. Whatever they write on the label is what you want to use. But if the label for some reason is missing that information, then you could take the volume over the strength, the milligrams over the total volume, and that would give you an approximate strength for that particular medication. So, all right, so I'll stop talking. If you have any questions, just type it into the chat, unmute, let me know.
So here we answered question C, correct? 1.7 would be the number of milliliters we would administer.
Correct. Yeah. So like this was taken out of probably like a textbook or something. And so the workup steps, the ABC, this is not a good example of a test question. What I was more focusing on was the label itself. The rest of it, you know how to answer, or at least I'm assuming you know how to answer.
So the dosage strength for B, it's in the instructions, right? So we are not calculating it here. It says in the instructions the strength of the reconstituted solution would be 5 milligrams per milliliter.
Correct. Yeah. And and like I was saying, the trick to this is that you really haven't seen a label like this yet. And I don't even know if you will see this semester. You might start to see it next semester. It really just depends on if they decide to integrate it. I just want to make sure, because you might see it on ATI, you might see it on NCLEX, but once you find that in the label, yeah, you don't need to do any kind of math to calculate the strength if it's listed for you in the label. And I think that's what you're asking me.
Okay, thanks.
You're welcome.